It's just another day of hard work on the yard for Greg. He just finished up maintaining his well-kept lawn. How beautiful! It would be a shame if something were to happen to it. Oh no! What's that? Those birds mocking all his hard work. All that Greg can think of is how those crows devastated his lawn all fall, winter, and spring. Greg thinks of a way to fix this common issue. How about installing some ultrasonic deterrents? No, that won't do. I hear that high-pitched noise all the time. How about a motion-activated water sprinkler? That scares them off. No, neither will that. The pests get used to it. The water's too weak, and plus, I always trip it by accident and I get soaking wet. Not to worry, my friend, because Varia Technologies is making the product just for people like you. Presenting Flood. We've put all the features you need that makes it an effective pest deterrent. It detects pests so that you don't get targeted. It uses the force of water to humanely deter the pests. You can also see the status of your flood and view its recordings. Currently, the flood is in the proof of concept phase. While waiting for approval, we developed the fundamental requirements of the product, such as hardware considerations, computer vision, and the transfer of data. Here is a glance at each of the requirements.
Hi, my name is Eric Wang. I am the Chief Design Officer at Variatech, and I am responsible for the mechanical design of the flood. I will be walking you through the SOLIDWORKS CAD model of the flood internals. Here, we see the 3D model of the flood internals in SOLIDWORKS. You can see the many mechanical components that goes into the device. Here, we see the servo motor, the nozzle, the water piping, the solenoid valve, the stepper motor, and the gear drive system. We can make some of these parts transparent so we can see the components better. The flood mechanically rotates about the yaw axis by the gear drive system as seen here. We drive this movement through a 1:6 gear ratio with the stepper motor, which allows us to minimize the torque requirements. This also allows for an opening through the center of the device, allowing our water piping system to pass through. The nozzle of the device will be controlled by the servo motor as seen here. This allows the nozzle to rotate about the pitch axis to our required angles. Let's see this in action. Simply perfect.
Hi, my name is Justin and I'm the electrical designer of Varia Technologies, and this is a physical proof of concept. We designed various circuits to control a servo motor, a stepper motor, a solenoid valve, and a camera. The circuits are implemented on a breadboard and powered using a lithium-ion battery. Using the Raspberry Pi microcontroller, I was able to write code that was able to turn on or off electrical devices and control speed and direction of the motors.
I'm Josh, one of the developers at Varia Technologies. Computer vision and detecting pests correctly is fundamental to flood. Since we're using a Raspberry Pi as the brain, we need to make sure the Pi can keep up with the animals that are being detected. So we've opted for using a quantized model, which takes the normal 32-bit floating point numbers and rounds them to 8-bit fixed point numbers, making the model smaller and faster. In our proof of concept, we're using a model that is trained to recognize objects such as people, dogs, cats, and birds. We're also working to greatly improve our accuracy for raccoons, squirrels, and crows, which were our priority as our most unwanted yard pests.
Hi, my name is Desmond and I'm the Chief Information Officer of Varia Technologies. Along with the flood product itself, there is a companion web application to aid our user experience and also increase their quality of life. Our first steps to doing this is to handle how we transfer data while keeping the consistency and integrity of the information that we send. For our proof of concept, we will initially connect our Flood's Raspberry Pi to our local computer to send data through SFTP. Our device is able to transfer data from the Pi to the local computer via USB, and once there, we run a Python script that allows us to connect to our Postgres database that is hosted on Heroku. In this example, we can see all the values currently stored in the database. We use a Python script that sends various SQL commands to push the data onto the database by using the credentials that are provided by Heroku. From there, our web app that is also hosted on Heroku is able to pull data from Postgres to display that data onto a web app, like the metrics from Flood's usage. In future iterations, we look to implement HTTP calls from the Raspberry Pi that will directly be able to push data straight into the Postgres database.
In the next iteration, we plan on developing the Flood to its prototype phase. We plan to upgrade the Flood by designing in the camera, the motion sensors, as well as the case for weather sealing. We will also be implementing an aiming algorithm using the aid of computer vision to correctly target the pest. We also plan to upgrade the system in how the user interacts with the Flood in the Web Companion app. We will provide a login screen, a dashboard to view and add your devices, as well as to see each device's statistics and modify what it should deter. These are some of the big plans prepared for the company, and soon, Greg can be confident that his lawn will finally stay pristine year-round, thanks to the Flood.